Welcome back to this video series of C++ programming. This is the lecture 7 of this video series, and today we are going to talk about inline functions in C++ programming. Inline functions are defined similar to a normal functions, but unlike normal functions, they are not actually called. Rather, their code is expanded inline at the point of each invocation. It is similar to using function-like macros in C programming. So inline functions, even though they are defined similar to a normal functions, their code is not actually called. So whatever the code inside written inline function is expanded at the line of invocation or where the function is called. Inline is a standard C++ keyword. Inline function may be a class member functions. When function is defined within a class, it becomes default inline function, if possible. We'll talk about this point when we see the example of inline functions. But the third point says inline function may be a class member function. So they can be members of classes and they behave similar to this first point. So let's understand the inline functions with some example. We create entry function to the program, that is main, and we include this IOStream header file and this using namespace std statement to support the input output operation. First, we'll see how we can use the inline function in C++. We'll create one function here. This is add function which adds the content of these two passed variables a and b and return the result of addition. Now inside this main function, I'll call this function and we'll pass these two values. And whatever the value it has written, I will print here. So since it is returning, the type must be integer. So this is how we can write a normal function in C++ programming. So when you call this function, your program then jump to this address where this function is located and then execute this functionality and return from this address back to this main function. So there is a change in the address, or you can call this as a context switch. Now this function, when you change to inline, so how to make this function inline, you have to specify the inline keyword before that function name. So now this function has become an inline function. That means when you call this function or invoke this function is not actually invoked, but the code within this function is expanded at this line of invocation. So instead of this add and 1020 inside the bracket, this code will be expanded. So it will actually put a plus b. So this is how the inlining is happening when you use the keyword inline. Now we talked in this when inline function may be a class member function. So let's see how inline function can be a class member function. For that purpose, create one class, so C1, and create one variable in data, which is a private. And then inside this, I'll create another function, say display data. and here we'll call this function. So for that purpose, first we need to create an object of that class, and with that object we can call this display data function. So now this is a normal member function of this class C1 display data. We can make this function as inline. To make this inline, as we saw earlier, you have to just specify this inline keyword. But remember, when you define a function within a class, then by default it becomes an inline function. So as we saw here, when function is defined within a class, it becomes a default inline function if possible. So this if possible, we'll talk about this the statement if possible in this later part of this video. But for now, understand by default the compiler will make this as an inline function if possible. That means you don't have to specify explicitly this inline keyword. This is already an implicit inline function. But when you move this function or when you define this function outside the class, then that time you specify the inline keyword. So this is how the inline function can be a member of your class, and then it can access the private members of your class. So here I have initialized the value of this data1 as 20. Now let's compile the code. So it has outputted value as a 20. Alright, so we saw how to create an inline function and how to create the inline function within that class as well. Let's talk about some of the important points related with the inline function. First, inline function allows you to create very efficient code, and it reduces the overhead of context switching. So every time when you create a function and invoke that function, as we talked in the previous lecture, the context switching happens. So what is context switching? So when you call a function or invoke a function, your address, your processor will jump to that particular address where that function is located. But since you have this function, suppose you're invoking this display data function from the main, whenever you invoke, your program will switch to the address of this display data function. But now this object 1 is a local variable to this function. Similarly, there will be many other local variables present in your function. And as you know, these local variables are present onto a stack. If you change your address of that memory location, the content of this local variables will be lost. And once you come back from this function, the previous values of these variables will not be present. Now, to avoid that, the compiler internally, when you call a function, it does the context switching. That means the content of this variable is stored somewhere in the memory. So when you come back, the original content can be retained. Similarly, the microprocessor will have some CPU registers that are associated with arithmetic or logical or many other operations. So these registers must also be saved. So they are also saved when you invoke the function. And so that is also when you call function, you have to save the current address of this main function, so that your compiler will know that from at which address you want to return back. So there is a lot of overhead involved in this operation. So because you have to say a lot of things, and every time when you call a function, this overhead of the context switching is present. So if your a function has a lot of temporary parameters or temporary variables, then the time that it takes in the context switching is more, and that is unnecessary burden to your processor. To avoid that, inline functions are very useful. So when you create inline functions, that the content of the inline function is actually invoked or replaced at the place of invocation of that function. So that reduces the burden of this context switching or function calling. So that is a very important advantage of inline function. Inline functions result in larger code size because of duplicated code. That means when you create an inline function, the content of this inline function is replaced and at the place of invocation. If you are invoking this function at the 10 different places of your program, the same content or the same code will be replaced. So that is a duplication of code and that will increase your program size. That is the limitation of inline functions. And the third very important point, like the register specifier in C programming, inline is actually just a request, not a command to the compiler. The compiler can choose to ignore it. Also, some compilers may not inline all type of functions. That means it is not guaranteed that when you specify this inline keyword, the function will become inline. It's up to a compiler. The compiler can decide whether he wants that function to make as inline or not, and it depends on many parameters. So if compiler thinks that uh, your function calling or context switching will take less time rather than replacing that function as it is at the place of invocation, that then it will remove this inline definition from the function and it will behave like a normal function. And how compiler can decide? He can decide based on the number of instructions. So if your inline function is taking more instructions rather than the calling, then he can compile the program in such a way that that inlining effect will be removed. So we talked about these important points about the inline functions. Let's talk about the difference between the macros and inline functions in C++ programming. So if you're from the C programming background, you must be familiar with the macros or the constants. Let's understand these differences. The first one, macro cannot access the private members of class. As we saw here, when you create an inline function, you can access the private members of that class, but accessing those through a macro is not possible. Second, and very important point, C++ compiler checks the argument type of inline functions and necessary conversions are performed correctly. But preprocessor macros is not capable of doing this. That means when you call the inline function, you can pass the parameters to the inline function and you are also returning the parameters from the inline function. So now compiler can check those parameters for the correctness. So that's the reason you are specifying this prototype. What is the prototype? Why prototype is required? Because it is one kind of type checking. So that means the parameters within this prototype and parameters with the function definition must be same. If they are different, then function will say there is a parameter mismatch, and that is a type checking. So with the function, your compiler can perform this type checking. So what parameter you are passing? Suppose you are creating one character variable and you are passing the value to this variable as a float, then your compiler might say this is not the correct value. So that type checking is possible in case of functions, but in case of macros, that is not possible. That is one advantage of creating the inline functions. The third advantage is, or rather advantage, the third point is macros are managed by the preprocessor and inline functions are managed by C++ compiler. So when you create a macro, like a hash define, say, uh, data and specify some values to that macro, then these macros are processed at the time of pre-processing. So these are the stages of compilation. So when first stage of the compilation is the pre-processing, where all these preprocessor directives, one is a macro, will be processed and compiler will replace the content of this preprocessor derivatives into your program. That is happen in the pre-processing. Followed with the pre-processing, the next stage is the compilation, where compiler will actually compile your code to determine the errors and warnings present in your program. And the function is managed by the C++ compiler, where macro is managed by preprocessor. When you create this function, it is processed by the compiler rather than the preprocessor. So that's why it is able to do this type checking for the parameters of the function. Sometimes macros will have some bad effect on your program. So if they are not used carefully, then they can spoil the program. Let's see how this can happen. So we'll see how we can use the macros here. First, I'll create one macro. So to create a macro, you have to specify this hash defined preprocessor directory and then the name of macro. So I'll create this macro as a cube. Normally, we'll specify the value to this macro. So wherever you are specifying this cube, this cube will be replaced with this value. Macro can be used similar to a function. So how we can use? So this is the brackets after this macro name contains the argument to this macro. So now x is a argument, and now when you call this macro, we can pass this argument, and it will be collected in this x. So this is similar to using the functions. So I will use this macro to determine the cube. So what it should output the cube of this 4. Let's compile the program and see what does it output. So it is outputting 64. So that's correct. Let's see what can be the side effect of macro. So now I wrote this code. Say this is a 100 divided by the cube of 4. Cube of 4 is 64, and then I'm dividing here. What I want is this 100 must be divided by this 64. Now let's see what does it outputs. Now to your surprise, it has outputted value as a 400, and definitely this is not a correct value. So 100 divided by 64 is not a correct value. So what is happening here? So what is happening is your code is now expanded like this. Now this Q4 is x into x into x. So this program is now expanded like this. And here, first this division operation is getting performed. So 100 by 14 is becoming 25. Then this multiplying with the 4 and 4. And that's why it is printing output as 400. So this is how macros can create a side effect in your program. But now if I write same program or same statement here and replace this cube with some inline function, say cube of 4, let's compile the program and see what does it outputs. So it is outputting 1.5625. It looks correct. So when you create an inline function, so this function here is similar to a function, but the code is expanded at this line. So instead of Q4, this code will be expanded. But here, since this is behaving like a normal function, it will perform this operation first, and it will replace the result of that operation on this line, and then this 100 is getting divided by that result. So which is what we want. But if you do this with the macro and if you don't use the macro carefully, then it will create a side effects. So this is how inline function can be safer. So to avoid this, I'll specify some brackets here, and with bracket I think it should work fine. Yes. So macros can be used in the program, but they must be used carefully. But if you are not sure whether they will have any side effects, especially when you are using the macros like a function, then it is good to use the inline functions, which is a powerful features of C++ programming. Inline functions are very useful in the embedded programming, where speed is very important. So where you want to reduce the processing speed, you can use the inline functions so that the time in context switching will be eliminated. So this is all about the inline functions in C++ program. I hope now you have understood the concept of inline functions. So thanks for watching this video and stay tuned for the next video.